Welcome to the fourth and final video for section 2.2 in calculus. And actually the next two problems are pretty straightforward, and the last two aren't really all that bad either. But here we go. So we're going to begin with example number 17. And basically what we're having to do is to fill in a table. By using this table, we should be able to determine what is the limit, perhaps, at least if we can think our way through it. So, rather than using it horizontal like they have it, I'm going to give the values in a vertical form. So it gives us x equals negative 0.1, negative 0.01, negative 0.001, and 0.001, 0.01, and 0.1, and we are asked to find the value for f of x, which is equal to x squared minus 5. And so just plugging this in and chugging away, we get negative 4.99, negative 4.9999, negative 4.999999, negative 4.999999, negative 4.9999, and finally negative 4.99. Now it should be really obvious that as we approach 0, because we are asked what is when the limit as x approaches 0 of f of x, when we get closer and closer to 0, which occurs somewhere between here, we are just getting closer and closer to the value of negative 5. Now realize this certainly would have been a whole lot easier if all we would have done would do direct substitution. Plug that 0 in there. 0 squared minus 5 is negative 5. But we are asked specifically, or just realize that this is a verification. This proves our point, I guess, basically. So in this case, the answer is negative 5. Now let's look a little bit differently at example number 18. Once again, we have a table, and it starts out with x, but then it asks what is f of theta. So it really should be theta. And remember when I warned you about college students giving the problems or setting up the problems? Here is a perfect example of it. F of theta in this case is going to equal the cosine of 8 theta all over theta. And we're asking what happens when the limit as theta approaches 0. That's what we're looking for. So different values for theta would be negative 0.1, negative 0.01, negative 0.001, and then the positives of each one of those. And it's very important to realize that we do want this in radians. We don't want it in stupids or degrees. For those of you that are new, degrees just don't make any sense, so make absolutely sure your calculator is in there. Now I will confess that chances are I may have had degrees in here when I calculated these values, so please excuse me, but you will notice that the numbers will be very similar whether they were degrees or radians in this particular case. So when I plugged it into this function here, I got 9.999025. 99.99025. 999.99999. 999.99999. 99.99025 and 9.99925. Now once again we are looking what happens when theta is getting closer and closer to 0. Now here's a little bit different, something that we have not looked at yet, and that is this is really close to 10, this is really close to 100, 1,000, so on and so forth. It just seems to be bounding extremely high at a very fast rate. Likewise, when we come from the other side, if we would be at 10 and then 100 then 1,000, so it seems to be just jumping dramatically. Now we know that if it seems to be jumping dramatically, where is it heading towards? It is heading towards positive infinity. Now that may seem somewhat awkward. Where is it heading towards? Well, if we think of limit as where is it heading and we say infinity, that certainly would be a legitimate answer, and in fact that is what the case is. Now the final two examples, we actually have to start thinking through and determining, what can we do with this? So let's look at example number 19. Number 19, we know that the limit as x approaches 2 of f of x over x squared equals 4. We want to find what is the limit as x approaches 2 of f of x over x. Now, in order to do this, the first thing we need to know is what is the limit as x approaches 2 of f of x? And we're going to have to use this equation here to do that. So, let's go and say, okay, I can take the limit as x approaches 2 of f of x, and then I can actually substitute in the 2 here. So 2 squared would equal 4. Equals 4. And now it becomes real simple. The limit as x approaches 2 of f of x would now equal 16. So now we have this information. So now to find this answer, what is the limit as x approaches 2 of f of x? Well, that equals 16. Then we can do the same substitution. X equaling 2 would go right there. 16 over 2 equals 8. And so the limit as x approaches 2 of f of x over x equals 8. And that is the solution to the problem that we are asked. And the final example for this section, number 20. We are asked what is the limit as x approaches 0 of 1 over x plus 5 minus 1 over 5 all over x. Now, first thing I would suggest doing, let's try simple substitution. 1 over 0 plus 5, well that's 1/5. 1/5 minus 1/5 is 0. Not looking so good. And then in fact when we put the 0 down here, we get 0 over 0, the indeterminate form. We are in trouble. So one thing that we might want to do here is get a common denominator in the numerator. But since we haven't substituted in yet, we have to be sure to carry that limit right along with us. So let's see, the common denominator would be 5 times x plus 5. And let's see, we would need to multiply this by 5. And we'd have to multiply this by x plus 5. And so this would be the limit as x approaches 0 of, okay, 5 minus x plus the quantity x plus 5 equals negative x. And there's really no need to distribute this 5 yet all over x. And we're still in problems because we're going to have 0 over 0, so we still haven't taken care of the situation yet. But now that will cancel with that, leaving a 1. And so now we get the limit as x approaches 0 of negative 1 over 5 times x plus 5. Now if we try a direct substitution, there's no problem because this will equal negative 1 over 5 times 0 plus 5, which is 5, and that becomes negative 1 over 25. Negative 1/25 is the limit of this.